Good afternoon, everyone, and welcome to the April edition of our waterproofing workshop series, Why Recurring Roof Leaks Continue Despite Repeated Repairs. Couple of things. We are using Zoom today, so please, if you can see the chat button, I will sort of try and be a bit engaging with the audience today and ask a couple of questions. Yeah, so we'll probably go for about half an hour. I'll try and keep it to half an hour. Sometimes it goes over to about 40 minutes, depending on the questions that we ask at the end, or we get asked at the end. But keep the questions at the end, and then and also please post your questions as well into the chat as well, so we can get a good read on what the audience wants to ask as well. Thank you for joining us, and yeah, sit back, relax, and please enjoy, and yeah, post some questions in as they come up. A little bit about me. I am the CEO of Danrae Group. I'm a registered building practitioner and waterproofer and builder. And my job is to build the company strategies, sales, and team development. And that's my lovely family there, my wife and my two lovely girls. And I am a blue belt in karate, and I studied at Charles Sturt, and I'm a committee member of the SCA and the ACRA Association. And we have a special guest here today from Soprema, Oliver, if you'd love to do some intros.
Yes, thank you, Daniel. So first of all, I'm not a karate specialist, but I know a little bit of other things. So I'm the regional manager for a company called Soprema. Soprema is specialized in everything that has to do with the protection of buildings, but then mainly waterproofing and thermal insulation. Myself, I was born in Belgium. I'm a Belgian citizen, but I've been all my life an expatriate, looking to distribute and support, let's say, systems from Europe and North America into the Asia-Pacific markets, including Oceania. So at the moment, I'm the regional manager for Australia and New Zealand. I have been around the two countries for the last 22 years, trying to learn more and more about the way that things are being built here and keeping up with the local compliance, for example. And my job is mainly, I'm the contact between one of our 130 factories that we have around the world. Yeah, see what systems could be beneficial to be implemented in the Australian market and installed by companies like Danrae, for example.
Awesome, thank you, Oliver. And Oliver will be joining us through the seminar today, and yeah, will helping me with some of the content and answering some of the questions today as well. So thank you, Oliver, for joining us. I'm going to dive straight in. So if you, I'd like to ask the audience a bit of a question here. On a scale of 1 to 10, how accurately do you believe that problems are diagnosed with regards to waterproofing? Just put it in the chat just to get a bit of a gauge from the audience on where you think diagnosis is in the industry at the moment. If you can find the chat box, a little chat icon in the toolbar. Yeah, nice. Yeah, so I've got a bit of a so mostly good, but then I've got 6 and then a diagnosed bit of hit and miss. So yeah, it is definitely a big problem in the industry, and as a lot of varied owners would know, strata managers and also consultants, you know, the diagnosis is it can be difficult if it's not methodical in the way it's done. So the reality out there is leaks keep coming back. Repairs seem to work temporarily if it's a low cost fix, and it's a patch repair, and then ongoing costs can keep increasing. So a lot of the issues is that if it's not diagnosed correctly, a lot of repairs are just based on symptoms, and then the root cause obviously remains untreated, the proper root cause. And then often with exposed membranes, waterproofing can be treated as a bit of a patchwork. So it's just localized repairs. Obviously, that's changed dramatically now, especially in New South Wales due to the Design Build Act. But we still see that occurring, unfortunately, in the industry. Main causes. So there's various main causes to defects. The common ones we see are actually compatibility issues, where there's an incompatibility between products and their use and where they should be applied, and design related issues as well. So we see a lot of issues around poor flashing, insufficient upstand according to the standard as well. Incorrect falls is another one that we see where areas are falling in the wrong direction, or the substrate's falling into the wrong direction. And then we also see maintenance neglect as well. So a lot of exposed membrane systems are not maintained, which is really against what the supplier recommends as well. But it's also, according to the standard, it's also important that you do inspect and maintain a exposed membrane in general. Oliver, I don't know if you've seen in your career some of these issues as well, whether you want to comment on that as well.
Yeah, definitely. And it's also the design wise. I mean, it's not only the architectural design that has to be looked at, but also the building will settle through time. So in the roof areas, for example, we have something called deflection. So the difference between your fall that you have on the architectural plan over time due to roof deflection, depending on the substrate of the roof, yeah, will bring that down. Sometimes up to 1%. So you're gonna have here and there ponding areas. So from manufacturer point of view, we like we know that it can happen, and we will try to make the products as robust as possible to withstand ponding water. But then still, maintenance is important because on certain types of waterproofing, you can have something that's called mud curling. And I think the facility managers that are joining us today, you can also see that if roofs don't get cleaned, let's say in a sporadic way, but in a regular manner, that all of these things will add some stress on the membranes, and it might decrease the lifetime a bit. So if you have good proper maintenance, you will really extend the lifetime of that roof surface, which is in the best interest of the building owner.
Yeah, nice one. Thanks, Oliver. So let's dive in. So design related issues. A lot of common faults around penetrations, how they're detailed, outlets, parapets, and the changes of plane, or also so for example, lapping joints, how they're detailed, the way the water falls to particular penetrations can all affect where penetration of water occurs in a roof. So design related failures, I'm sure Oliver, you've seen quite a few design related failures as well on rooftops. Any particular that come to mind?
I think you mentioned a few already, but
Yep.
the heights that we stipulate as manufacturers, or the ones that we find in the Design and Build Act, they are there to follow. I
Yeah,
mean,
nice.
that is not only there just to fill up some paper, but it's necessary to follow these manufacturer guidelines because this has to do with drains that get stuck again due to low maintenance sometimes, and that can cause really headaches for the building owner. But also the not checking the compatibility of a drain outlet, for example. If you look at siphonic drains, for example, they can come with different flanges that are actually subjected to the type of waterproofing you're putting on that roof area, whether it's a modified bitumen membrane or a single ply PVC membrane. So it's very important that all the components that are touching the waterproofing are compatible, and that the membrane can be secured, for example, with a good quality clamp ring drain where you can mechanically squeeze the membrane around that drain outlet. So there are definitely ways to improve the durability of these systems by just choosing the right products.
Yeah, which is the clamping drain. What Oliver mentioned is actually the photo from the standard that's on the screen now. So that is a drain essentially that gets screwed in, and then the clamp then obviously just pushes against the membrane that's turning down. The other detail that I've got the photo that's straight out of the standard as well, which is the how a membrane, or generally speaking, we see this detail on a sheet membrane that gets regulated into the upstand of or the parapet, and again the membrane actually gets turned in and then epoxied. So the water actually flows over and up and over the membrane, so that you're not getting an exposed edge on that wall where water can then penetrate behind that membrane. Some detailing. So penetrating detailing. So I've got a couple of photos here. A lot of what we see that gets or detailing issues in a roofing membrane from solar would be one of them. And I have showed some in particular some Soprema products here that for detailing of particular penetrations through a membrane. Do you want to cover these, Oliver, just quickly on what they are and explain it to the audience of what a couple of these are?
Yeah, what is interesting to know is that as manufacturers, we are going to look at certain issues that designers have. And due to the rise of the use of solar panels on even on larger industrial roofs, what we call solar farms, but as well as in housing applications, is of course the number of penetrations that you get when you have to put the solar panels on the roof. So we have developed a system called Sopra Solar, which is compatible to the roof membrane, to our roof membranes, whether they are bitumen or single ply membranes, but they do not penetrate the roof as such. So we have done the wind case testing and wind tunnel testing. So we also calculate the wind load design pressure on that roof area, and then we can design how many of these pedestals you need. But to make a long story short, they do not penetrate at any location the primary roof waterproofing membrane, so giving a very safe solution to the building owner. What we also see, and especially in renovation, is that we don't have chance to talk to the architect anymore to put those pipes a little bit further from the wall, so that Danrae can actually apply nicely the membrane around it. So for these things, we have developed smart solutions like our ChemLink penetration seal systems, where you can actually build a form type of formwork around these penetrations and fill them up with a portable sealant. Now, for those who have been around for a longer time, these were done in Europe a long time ago, or in North America, with actually pouring bitumen. So these have now been upgraded to let's say, very robust UV resistant pouring sealant products. So smart solutions to really cope with those difficult penetration details, or in the case of Sopra Solar, eliminating penetrations at all.
Yeah, nice. So we've actually used this product a number of times now. So essentially forming up, so you don't have to worry about forming up formwork. It's essentially forming up these plastic these plastic form made up, and then you pouring in the products in there, and it's essentially sealing the penetration. So it saves a lot of time and a lot of work when you're getting difficult penetrations on the rooftop. So really good product.
Mhm.
Other issues in defects we've got. On the one photo on the left is a typical torch on where it's turned up the parapet wall, and obviously you can see there that the joint sealant is not in great shape, and it's the wrong joint sealant. So we see things like that a lot in maintaining a roof or looking at defects. And then you've also got the lap joints in any sheet membrane are a potential failure point. So that's definitely something that has to be checked. And then also the corner detail, the floor wall junction detail is often an area of failure. In this particular drawing, the membrane was just turned up in one go, so shouldn't be done that way. Obviously, it should be done floor and wall separately. So yeah, that was a fault and defect that we've seen and had to repair. Going into thermal systems with insulation on roofing. This drawing here is a common design where the insulation is installed on the underside of a slab, which creates condensation between the slab and the insulation, enabling moisture to be contained there. So that can obviously lead to other like algae or molds to grow. This showing you, from that old design, there's also a design where the insulation is over or on top of the slab, where you've got the slab, the membrane, the insulation, and then some sort of pebble or paver system. The problem with that traditional roof design also is that a lot of the older insulation would retain water. So that would be the problem with that would be that it negates any sort of insulation advantage. Because once the water is held in there, any sun or heat or anything like that is directly transferred down into the slab. The other issues that we've seen in this scenario is that the having pebble is, while it's aesthetically it looks good, it can be quite a maintenance issue where a lot of soot, dirt, things like that end up in drains as well. And it's not a very good design to maintain the roof. So it's very difficult to inspect the roof, etc. Or inspect the membrane rather than while it's obviously covered up. So that's a bit of a difficult design to work with. The design on the right, it shows a metal roof and then the insulated system on top. However, it can also be applied to a concrete roof as well. And Oliver, you want to explain that system, the warm roof system, inverted roof, what they call
Yeah,
it.
so
Yeah.
Yeah, so overseas it's called the warm roof system. In Australia and New Zealand, we call it the insulated roof system because it's a little bit different how it works with the temperatures compared from where it originally came from. But these are tested and proven systems. They are very, very common in all types of buildings in North America and Europe. Basically, what that is, if you would see the previous slide, you will see that the insulation is under your roof slab. So that means the dew point is within your roof cavity. So what we try to do with the warm roof is to actually play, and also what you see on that picture is that under the roof you have a lot of penetrations, like you have the walls, you have supporting columns, things like that. So what we try to do is to make a continuous layer of insulation in order to increase the thermal efficiency of the roof concept. So the more continuous insulation is, the less thermal bridging you have. Plus, by putting that on top of the roof, we now control where the dew point is formed by playing with the thickness of the insulation and by incorporating a vapor barrier in between the carrier substrate, whether it's metal or concrete or even wood or CLT. And that actually protects the whole roof in a much better way, and not only waterproofing wise, also thermal insulation wise. And also with Danrae, these can be installed on existing metal roofs. So if you're looking at an upgrade or a recover system, we also have solutions available for that. So that are the main benefits of that roof. And then one big difference between left and right is, of course, the weight. If you look at the renovation or refurbishment scenario, you can't use the left one due to the weight you have to put extra on top of that roof. So we have lightweight systems available that can cope with existing metal roofs.
Yeah, nice. Nice. So going into materials, I mentioned this earlier, but there's chemical incompatibility, delamination and layer separation and performance impact. So these are what we see. Unfortunately, in remedial, there's some instances where these issues still occur. And I've had a question in there about the engineer, and yes, the engineer or the design practitioner is the one that would design how the installation is done, and it's up to then the building practitioner to install it that way. Unfortunately, though, we still see problems with some of these defects where not only in New South Wales but also in other states where the design and the installation isn't done in my words, would be sort of properly or to the standard needed. So we see a lot of these still these issues occurring in remedial. These are just examples of what's seen in defective membranes. So ponding water is one. Blisters where you're getting air underneath the membrane or it hasn't cured properly and the second coat's been installed. So some membranes are actually moisture curing and some of them need to release vapors to actually cure. So what happens is if you contain it and the first coat hasn't cured properly, you will get bubbling forming on the membrane. And then other one is cracks and shrinkage. So yeah, obviously the expansion and contraction of a substrate can cause this, and the membrane needs to be applied. If it's a liquid, needs to be applied at the correct thickness and at the right time as well. I've included this slide. This is an interesting. This is a metal roof, but I know in remedial we see quite a lot of metal roofs and leaking in box gutters. So I wanted to sort of mention this about what while a box gutter or metal roof can be installed to standard, there are issues with this type of installation where if, for example, the box gutter backs up and there is like the water can't get away quick enough, the water can track it sort of up and into the roof area, into the roof cavity. So the point I'm trying to make is that these installations can be totally compliant, but it's only weatherproof. It's not waterproof. So when you look at design in remediation, there are designs that you can do to make a metal roof totally waterproof by overlaying a system, which is one of the systems that we mentioned earlier. And I'm sure Oliver, you can probably comment on that as well.
Yes, one of the questions that we get often asked is what type of membrane or what type of waterproofing system do you recommend here? And I think this is a perfect example of looking at a certain situation, looking at your portfolio of products that you have available, and then you can say like, look, most of the time these box gutters, they are wide. We need a good evacuation of rainwater, so meaning not too many laps as such. So you would rather go to a single ply membrane, like a PVC membrane, where you can have really wide rolls, long rolls that can be nicely installed into that gutter with almost no laps. And then you actually have a second skin, let's say, on top of that metal, which also protects it from corrosion over time. So for the building owner, there are a few wins in there, not only to stop the leakage, plus you can bring it, if you open up the metal on the bottom side of where it lands into the gutter, you can actually bring your membrane further under that. So also wind-driven rain gets dealt with. So there are a few positive ones on this system, in my opinion.
Yeah, nice. Okay, so going into what's out there, membrane types. So I've grouped generally into three types, and we see three main types really in the industry. Liquids, and to preface this too, all membranes have their place in remedial and in any waterproofing situation. But I do show this to give people a bit of an understanding generally of membranes, so that you've got liquids that are quite easy to install. However, they do have limitations on when you can install them, such as parameters of the substrate, moisture content, ambient air temperature, things like that. So the installer is very heavily reliant on the installer on the liquid to ensure that that's done correctly, right thickness, all that kind of thing. Generally speaking, you'll get generally speaking, a 5 to 10 year warranty. Some manufacturers will offer longer, depending on the number of coats, etc., on it as well. And then you've got a general lifespan. You'll get sort of 10 years plus with a membrane. Look, it also depends where it's installed, right? On lifespan. Bitumen sheet, torch on membranes. Look, generally we see 20 years on a bitumen sheet. Some limitations on bitumen. Some of the issues with bitumen is that the top granule on a bitumen membrane can sort of wear away, and that becomes a bit of a limiting factor of how long that membrane can last. Because once that granule wears, that's the UV protection of the bitumen. But generally we see, a lifespan. If it's maintained, you'll get a sort of a good 30 years out of a good bitumen membrane. And then the last one, you've got PVC rubber, or butanol sheets, all sort of single ply type membranes that are installed or welded with a heat gun. Generally speaking, we see these last a very long time if they're maintained, and you'll generally get quite a good warranty out of these as well. So if you compare material cost, most of the time the PVC sheet or single plies will be the most expensive. However, if you look at holistically on a project, for example, it might be more cost effective to install a PVC rather than say a liquid because of all the other things involved, like things like preparation, other factors that might be involved to remove the existing liquid or to install that liquid. It actually may be more expensive, or if not the same cost. So they're the couple of things to consider when looking at different membrane types. Maintenance. So, Oliver, I know you've probably seen a couple of maintenance issues in your field as well. Like from your experience, what are the sort of main things people should look out for with regards to maintaining an exposed membrane in general?
Yeah, I think during regular inspections, like ideal two times a year is ideal. One before winter, one after winter. But what do we see? We see sometimes damages by other parties that have to work on the roof, whether it's to maintain something or install some extra roof equipment like heat pumps and the like. So yeah, damages that happened involuntarily but didn't get reported. Also, due to, for example, algae growth on some products, that is something that has to be looked after because over time, certainly in the shadowy areas of a certain construction, meaning in certain gutter areas or near to walls, algae growth can be persistent. So there are, let's say, bio-friendly ways to remove those easily. But again, it's somebody has to remove them, of course. I think blockages, if you're in a very forested area or green area, so things like leaves and the like that block up the drain outlets. So you're relying on your overflow if there is any. So that is not ideal as well. The quicker we can evacuate the rainwater from the roof, the better. And then some, like you already explained on one of the other pictures, that is accessories. So products that are not really the main membrane, things like sealants, screws to fix the pressure seal that might not be stainless steel but are being corroded. Certainly for projects near to the sea, corrosion resistance is an item you have to look at if you fix things into the wall, for example. So there's a whole array of different things that can be detected early by doing roof maintenance inspections. And then if that is done by a waterproofing specialist, they can immediately rectify them in the same go. So again, good for the lifetime of the product or the roof cover.
Yeah, definitely. And one of the things we find in maintenance as well is that owners aren't fully aware of the total cost that the defects have built up to. So what we find is it's the accumulation of the repeated repairs that's the big killer. So they don't realize that remediation sometimes, if it's done early and quickly, there's a lot of damage costs that can be prevented, just simply because of the timing, and they don't realize the total build up of the total costs of repeated repairs. And another one that we may not have mentioned was disruption costs. So they're often the unseen killer of remedial, especially when you look at removal of existing surfaces, for example, an existing metal roof or existing membranes, and people aren't considering what happens during the remediation and what do we have to do to ensure owners are looked after. Do we have to relocate them, etc.? So that's why looking at different solutions such as membrane versus or re-roofing versus metal roof overlay, for example, we don't have to remove the metal roof. So things like that have to be considered when you look at a total cost of remediation on a building.
Yes, we see a trend in Europe as well to reduce wastage. So wastage gets billed now and invoiced a lot of money in order to get rid of it. So also being in a city area, for example, it's not that easy to start removing existing membranes and disposing of them. So what we are looking at as manufacturers is smart solutions on how to re-waterproof the roof without relying on the material that is there, because we don't know the adhesion strength of that material on the long term. It has all the possible problems that you have showed in the previous pictures. So we have techniques like mechanical fastening, for example, of membranes to actually not rely on those layers, but still leave them in place. Now, it all depends on the health of the substructure, for example, and the condition of the substructure. But there are smart ways about that we don't have to remove all the existing waterproofing and dispose of it.
Awesome. And so just to continue with maintenance, the other thing we see is just so owners understanding obviously their duty to maintain under the legislation, and also understanding the obligations of warranty. So supplier warranty, please read the supplier warranty because that's really important on the product itself, because a lot of we find that owners often get confused about supplier warranty or product warranty and then the installation warranty in a particular remedial situation or membrane install. So it's just understanding the obligations under that, because warranties are given under certain conditions. So for example, inspection, cleaning, etc., they're a condition of the warranty to be maintained. If there's no proof of that, or then the warranty may be void. So there's just things to ensure that's understood when installation is complete. Okay, last slide. So look, designing for the long term. I'm sure we've sort of shown a lot of the issues with temporary patching, no maintenance, things like that lead up to the long-term defects. And there's also, a lot of benefits around designing long-term as well, which Oliver's also mentioned around solar, but also, the energy cost savings, adding thermal insulation in design, things like that, not only conforming with the NCC, but also the benefit of actually cost saving with energy. I think the approach that I obviously talk to a lot with a lot of design practitioners is looking at the total roof design long term and what are the owners planning to do long term, just to incorporate that initial remediation. And like, for example, how were they going to affix solar to that? Do they plan to put temporary grass up there, etc.? So things like that to understand longer term what they actually want to do. I don't know if you've got any comments on that too, Oliver.
Yeah, so I think we face it a lot, that people are a little bit tired of getting all the excuses regarding to warranties, for example. So we have market research also has shown that building owners these days are looking for some extra security. So for that reason, Soprema also has an in-house technical and designing support team. So if we go into a maintenance scenario, there is not always an architect involved. So we will support with wind load calculations, so we can determine the quantity of fixings following Australian standard 1170 wind action. We will, if the client wants to have some more thermal comfort under the roof, we can add an insulation layer, for which we then do an automatically a condensation risk analysis showing the thermal performance of that roof after remedial works have finished. And then, of course, we can also team up with a selection of applicators that we know won't cut corners, have been trained in Soprema systems, and then we can go to special warranties, as you mentioned on the slide as well, which in our case is a platinum warranty, where actually Soprema, on top of the local warranties by applicator and material manufacturer, we also give a Soprema supply and install warranty for the whole period. So that also takes out those differences sometimes that material is 20 years, but installation is 3 years or 5 years. So we have with the right platinum applicators, platinum warranty applicators, we can offer long-term solutions with fully backed warranties for the client. And I think that answers this whole question on long-term solution with security.
Yeah, awesome. No, nice one. Thanks, Oliver. We've actually come to the end. So if you want to snapshot that QR code, we will send you a CPD point for this presentation. And you can sort of keep that for your records. We can email that through. We'll also go to some question time too. If I'm happy if you'd like, because we've enabled the audience to unmute as well. Or if you wanted to post your question in the chat as well, we could answer some questions. And also we've also had some people post some in as well. So I'm happy to maybe start with them as well. If no one's got any questions, we can sort of start with some of the that have been posted in. Let's have a look. Okay. All right, so let's start with Justine. So Justine's asked, who holds the responsibility of the warranty of any remedial works? If it is the waterproofer and they go bust, who is next in line, and so on? Interesting question. So depends on the state you're in, but if we're in New South Wales, that would fall under likely the Design Build Act. So there is essentially two main legal aspects or ownership within the legislation. So there is the design practitioner, who is essentially the person that puts the design together of how the waterproofing should be done, or the building element as such that should be designed and with the waterproofing in it. And then there's the building practitioner, who is the installer. So the building practitioner is actually a builder or a Class 2 accredited builder that does the installation. So no longer can a waterproofer as such, or only a certificate-free qualified waterproofer, they cannot actually do that work directly under the DBPA. It has to be under a building practitioner, right? So if the waterproofer goes bust, then that falls on the building practitioner. Then if the building practitioner goes bust, then basically, depending on what's happened, there'll be recourse under the builder. So the builder takes full ownership of that work, right? So they have to chase him him or her, sorry, the company for that work, right? That's how that process will work. There are certain guidelines around calling upon the insurance or the homeowner's warranty insurance, but that's quite limited too. So if it gets to that point, then the owners would have legal recourse under the contract to go after the builder. Hopefully that answers the question on that one. Let's go with this one. Maybe Oliver, you can chime in on this one. What is involved to include insulation when waterproofing a flat concrete roof? What's involved is quite broad.
Yes.
So maybe just the quick process of how that's done.
Yes, I read the question. Was indeed an
Yeah.
interesting question. So first of all, height restrictions, right? If we add a certain insulation layer to the roof, we have to check all the elements of the roof, including the roof edges, any equipment that's there. So most of the time, it might require some minor alteration work to lift certain plinths or whatever to allow the extra thickness of the insulation. We have to see that the roof edges are high enough to add that extra thickness. Then there is the issue. Normally, if we go for a renovation scenario, then often in most of the cases, the existing waterproofing becomes a vapor barrier. Right, so the insulation is put on top, and then we have a new waterproofing cover. Another thing there, it's a lightweight system, so the mechanical fixing of the system or adhesive bonding of the system will also have to be checked, and that we do by means of a wind load calculation. And we as manufacturer know the performance of our different roof systems. And then the last thing is the fall that you have on a roof, whether that's sufficient, because you can actually, in a lightweight manner, add tapered insulation on top of a concrete deck or another roof that is not really falling to the drain outlets in an appropriate manner. You can actually increase or reinstate the slope of a roof by using tapered insulation. So that's an insulation that has the fall inside the board, and in that way you have a very straightforward answer to bonding on roof areas, for example.
Awesome. Thanks, Oliver. I'll go one more question because we've run a bit over time. If there's no other questions in the chat, let's cover this one. So, practical advice to adjust thermal variations in the treated surfaces during the changing season. Example, scorching hot summer versus cold winter. That's an interesting one because you would design the thermal or the thickness of the insulation based on, well, NCC, but also what you needed to create the correct fall as well. But also, so Oliver, you might be able to add to this one too, but you're actually trying to conform with the correct areas of the code, right? That's what my understanding.
Bring the building up to the code, which is
Yeah,
always good
that's right.
for
Yeah.
resale value and things like that. Engineering wise, you would also look at the dew point. So sometimes that extra layer is not going to solve the condensation issue if there is a condensation issue. A lot also depends on what we call the climate class of the building. I'll just give you two examples, like a non-conditioned warehouse compared to a spa room or an internal swimming pool, which is heated. Totally different humidity classes. So we also take that into account when we design vapor barrier and thickness of insulation. So, but external climate, what you can expect in winters, it's also an important factor. What we do try to do and consult on with our what we call a condensation risk analysis is not to over insulate, because insulation is not the cheapest component of an insulated roof system. So, and there are, if you go over a certain thickness, then you're over insulating, which doesn't add much to the energy cost efficiency anymore. So we really try to design that, and we take into account the location of the building with regards to we normally go to the nearest weather station and look at historical climate data.
Awesome. Great information, Oliver. Thank you so much. Well, we've come to the end of the presentation, everyone. So thank you so much for your time. Please reach out if there's any questions as well, any additional questions. Our details are on the screen at the moment. Thank you so much. Look out for the next webinar. We normally will run these every quarter. So we should see one in June. We'll look at the next one. You'll start seeing some information on that online. Thank you so much for your attendance, and I hope that was really informative. Thanks again, Oliver from Soprema. Thank you so much for joining us.
It was a pleasure. Thank you for the invite.